Today we're going to be looking at lesson 41. And I think 43 is the other lesson that we're going to be looking at today. But both of these lessons are centered around finding the slope of a line. All right. And then forever, moving forward from here, when you read the words rate of change in a word problem, I want you to immediately think slope. What is the rate of change of something? We're talking about slope if we say rate of change. Now, as you move higher up into mathematics, you're going to be dealing with average rates of change, instantaneous rates of change. The first half of calculus, most of calculus 1, is directly related to rates of change, particularly the slopes of non-linear functions, okay? Because we can talk about the slope of a line. You guys have a lot of experience with that. But we could also talk about the slope of a nonlinear function. What's the average rate of change? What's the instantaneous rate of change? And those equate to velocities, the average velocity, the instantaneous velocity of an item or of an object. Okay? You can use mathematics to calculate all those instantaneous rates of change and speeds. So rate of change, guys, rate of change is slope. All right, so slopes and rates of change. Slopes and rates of change is what we're working with here. So let's have a look at some differences or some definitions here. A rate of change is a ratio that compares change in one quantity with the change in another. Okay, we've already defined rate as a ratio that compares things in two different units, right? Miles per hour, gallons per minute. You know, those types of things. We had some rates on our previous test, but a rate of change is a ratio that compares the change in one quantity with the change in another. For example, the speed of a car is a rate of change that compares the distance to the time traveled, right? Does that make sense to you? The rate of distance equals rate times time. So the rate, if we solve that literal equation for R, we get R equals D over T. All right, so R equals D over T. I don't know why that's not showing. We've got some slowness here. R equals D divided by T. Okay, so the speed of a car is a rate that compares distance and time. Okay, it's a rate of change. Rate. That's why it's given as miles per hour or feet per second or kilometers per hour, all those different types of things. Okay, a car travels on a highway at a constant speed. The graph shows the relationship between the distance traveled and the time traveled. Find the rate of change. What would the rate of change be here for this one? Rate of change? Where'd you get that from?
For every increment it moves to the right 1, it moves 60 up.
Okay. So what are you saying that the rate of change is?
60 miles per
60 miles per hour? Does everybody agree with that? That makes sense, right? Because a rate is distance over time, and so that's 60 miles for every hour is the rate that is being shown here. Okay, what about this one? Read that out loud for us, Sean.
A shop charge a fee for renting kayaks. What is the rate of change for the rental fees?
Okay, the rate of change for the rental fees. What would it be? $28 for every 2 hours?
32 for 2
32 for 2 So it's 16.
If we made it go up, so it's like.
$16.25.
All right, so if you're saying, those of you who are saying $16.25 for 1 hour, which what are you using there?
Well, you divide 32.50 over by 2, and you get 16.
So you're using one quantity. Can you use one quantity to determine a rate of change? No. How many quantities do we have to determine a rate of change? 2 quantities to determine a rate of change. And if we have 4 quantities here, it could be a trick question, right? Are we assuming that the rate of change is constant? All right, so what this, we are. We're having to make that assumption that the rate of change is constant, but the rate of change has to change from something to something. All right, so 60 minus 38.50 is 28, right? How do you get that?
32 plus 28 is 60, or 30.
60.5 minus 30.5 is equal to 28. And then the change in time there is 2 hours. So it looks like the shop charge is $14 per hour. Now, how could we explain this then?
It has
There's a minimum of 2 hours. 2 hours costs you $16.25 for the first 2 hours, but after that, it's only $14 an hour. Okay, so this is a minimum charge. This would be a starting point. Okay, and then you go up from there. Okay, so the rate of change here, based on the information given, is $14 per hour. Now, you guys you fell right into the trap. A lot of you said, oh, we just need to divide that by that, and that'll give us this. And that might have worked, and you got $16.25, right? But is 4 times $16.25 equal to $60.50? It's not. Okay, 4 times 16 is 64. 64 plus 4 times a quarter is $65, right? So this is not the rate of change. Okay, the rate of change tells us. So the way you would interpret this graph is that the first 2 hours, it's a minimum charge of $32.50. After that, it's $28 for each 2 hours, or $14 per hour, you know. I don't know how would you interpret that based on what's given here? Would it be $28 per 2 hours? Okay. Would you have to accept this answer if it was given? I'm just making you think. Why would you have to accept this answer if it was given? Yeah, so maybe this place only rents it in 2 hour intervals, you know, and not one. So because the table kind of indicates, okay, the first 2 hours is going to cost you $32.50. Every 2 hours after that, it's going to cost you $28 additional dollars. Okay, so $14 per hour is okay. The $28 for 2 hours is also directly what this chart is telling us. Okay, is the rate of the rental fees. Okay, so just kind of be careful with things like that, and be prepared to make an argument for your answer. All right, now here's the definition of slope. Some of you guys have already used this today in class, so I know you're used to this concept. Slope is equal to the rise over the run. Now this is talking about the slope of a line. All right, it's equal to vertical change. I like the way they write that there. Over horizontal change, or rise over run. Okay, so the slope is, I like it, vertical change over horizontal change. Extremely important that you do not get those mixed up. That's equal to rise over run. Have you heard the slope interpreted any other way? Change in y over, right? So your vertical change over your horizontal. We could say this is change in y, and I'm going to use a mathematical symbol for change here. Delta means change, okay? change in y over change in x. All right, how do you find the change in your y coordinates? How do you find the change in two numbers? What's the change from 1 to 5? How do you find that? 5 minus 1, right? And the change in x is 3. From 1 to 3, that changes. 3 minus 1 is 2, right? So the change in y over the change in x actually gives us what's called the slope formula. This particular Unit 41 doesn't cover the slope formula because you guys are in an honors class. We're going to do 41 and 43. 41 is just wanting you to count the change in y over the change in x. 43 includes using the slope formula. Okay, so the other lesson that we're going to do, that we're covering here, actually incorporates the slope formula. If we have 2 points, okay, let's just call it A. Point A is just some random point, x1, y1. And point B is x2, y2. The slope of line segment AB is equal to the change in the y coordinates over the change in the x coordinates. Okay? Is this familiar to you guys? Y'all are staring at it like it's Chinese. It's not familiar at all, this is the slope formula?
The way you're doing it is a little more complicated, but I see that.
This part looks familiar? Does this part look familiar?
The part below it looks familiar. That's this.
Okay. Oh, great. All right, so then y'all need to write this down. Make sure you write this down. To find the slope between 2 points, you subtract the y coordinates and you subtract the x coordinates. So we've got 2 points. You got to be able to read this notation too, right? x1, y1. That's a comma. Make sure we got that as a comma. Let me do that better. I can do it better. I can do a better comma than that. How about that? There we go. Ah, hush.
Like X and 11.
You just make your comma look pretty then.
11.
The lines in the comma look the same.
Yeah, I was like, hold on. What's
So like X sub 11. What?
Yes. All right. So x1, y1. That's just 2 random, it's just, that's the coordinates of that first point. And B, x2, y2, that's the coordinates of a second point. Now, does the order of the points matter? If I have the slope between 2 points, if I have a slope of a segment between these 2 points right here, these are just 2 points in space, right?
Hi guys.
All right. Does it matter if this is point 1 and this is point 2? Does it matter? Is it going to change the slope if I make the bottom one 0.2 and the top one 0.1? Does it change the slope? No, the slope's still the same. The rate of change is still the same. The rise and run is still the same. So what I'm trying to illustrate is that these subscripts are just completely arbitrary. It does not matter if you have 2 points, which one you call point 1 and which one you call 2. It does matter that you get your x1 and your y1 from the same point, and that you get your x2 and y2 from the same point. That's the only thing that matters. That's why it's ordered the way it is. So you can find slope by subtracting either point as long as you do the order the same in each one. Okay? So change in y over change in x is subtract the y coordinates, subtract the x coordinates. All right? So let's do this by 2 ways. Let's count the rise and the run. What's the rise and the run of this line?
2 and
Looks like we're going to rise 2 and run 4. So it looks like our slope is 2 over 4. Now, let's keep in mind here, guys. Y'all listen. Listen. Slope is rise over run. If I'm going up, that's positive, right? If I'm going right from that point, that's also positive. Now, if I went from this point to the other point, if I wanted to go down to, what's that? that's negative 2, and left 4, that's negative 4. We still have a slope of negative 2 over negative 4, still is going to simplify to give us positive 1/2. Okay? So we get positive 1/2 no matter how we count the slope. This is illustrative of what I just said. It doesn't matter which one is 0.1 or which one is 0.2. Doesn't matter if we start on the bottom or if we start on the top. If we do our rise and run correctly, we get the same slope. All right? What about the right here? Let's use the formula for this one. Okay, the previous formula we looked at was slope equals, what was it? y2 minus y1 over x2 minus x1. All right, now it doesn't matter which one is x2, which one is y1. It doesn't matter which one. Let's let this be our 0.2 and let this be 0.1 down here. Okay, all right, so we'll do y2 minus y1 would be 1 minus negative 8. It's going to be 1 plus 8, right? x2 minus x1 is going to be 1 minus 4. Y'all aren't writing this down. That's confusing to me. That gives us 9 over negative 3, which is, 9 over negative 3 is negative 3. If you wanted to put it over 1, you're welcome to. What would we get if we changed the order of these? What if I made this 0.1 and this 0.2? Will we still get the same thing? y2 minus y1 is negative 8 minus 1. x2 minus x1 is 4 minus 3. That gives us 4 minus 1, sorry. That's negative 9 over 3, which is still negative 3. Okay, the slope of the line stays the same regardless of which one is considered 0.1 or 0.2. Now you can always count rise and run, right? You can always count rise and run, and that's okay. Now what have we established here? What do we know about this line? And it has a negative slope. Can we tell that by looking at it? Yes. Negative slopes go downhill. This actually has a pretty steep negative slope. Okay? All right, so we can kind of see this make some deals, right? A line with a positive slope rises from left to right. Lines that have positive slope look like this. It rises from left to right. That's positive slope. And I'm telling you, there's a lot of eliminating of answers you can do on the ACT just by knowing this, just by being always cognizant of the fact that positive slopes are up and to the right, negative slopes go down and to the left. Okay? This is negative slope, down and to the right. Negative slope. Right? Positive slope. Very important concept. In calculus, functions that go this way are said to be increasing functions. Okay, it's increasing if it's going up and to the right. Negative slopes are decreasing functions. Okay, or it's decreasing. Then you can have a function that looks like this, right? Over here it's increasing. In this area it's decreasing. In this area it's increasing. Guess what it does between when it's increasing and decreasing? It has a slope right here that is 0. You can't go from increasing positive to negative without passing through 0. And you can't go from negative to positive without passing through 0. Okay? And this has something very, 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 very much to do with horizontal and vertical lines. Okay? Now, as this function is increasing, right? Does everybody understand what I'm talking about? Over here, I'm increasing because my slope is up and to the right. Right here, I'm decreasing, which means my slope is down to the right. Okay? What's the slope doing right here at the peak?
Nothing. It's not increasing or decreasing.
Looks like it is horizontal, right? This one over here, if I drew a a line that mimicked it, it would go like this, right? This side, this has a negative slope over here. In between those two things, the slope is horizontal. Okay, so the slope of a horizontal line is 0. All right, the slope of a horizontal line is 0. Very important. Extremely important. Muy importante. That's Spanish for very important. And I think they created that phase or created that phrase specifically to talk about horizontal and vertical slopes. Okay? Now, the slope of a vertical line, y'all listen. Shh. The slope of a vertical line is undefined. Listen. What else in mathematics is undefined?
Pi. Anything divided by 0.
Thank you for an intelligent answer. Anything divided by 0 is undefined. Yeah, and listen, I want to make that make sense to you in this context. All right? How would you describe a horizontal line as it relates to rise and run? A horizontal line is this way, right? Is it rising? No rise, but it's got a lot of run, doesn't it? And 0 divided by anything is equal to 0, right? Now, what about vertical line? Rise over run. Vertical lines have a ton of rise, 0 run. And division by 0 is undefined. Okay? So that's kind of how I want you to remember it. The definition of vertical, horizontal related to slope, horizontal lines all run and 0 rise. Okay, so 0 is up top. Vertical lines have all rise and 0 run. If there's a 0 under the line, the number is undefined. Okay? So 0 underline is undefined. We can't have no run, all rise. Vertical lines have a slope that is undefined. It's also called no slope. Vertical lines have no slope. Horizontal lines have 0 slope. This is extremely important. No slope. Okay? All right. What's the slope of this line? Why? Because it's horizontal, right? But if you wanted to apply the slope formula, the change in y is 4 minus 4. Change in x, 6 minus 2. That's 0 over 4, which is 0. Now, if you give me this as any answer on a slope problem, I am going to count it wrong. Because I need you to know that that equals 0. Okay? All right, what's the slope of this line? Same line. Why? Because it's vertical, right? But if we use the slope formula, change in y, y2 minus y1, 8 minus 4 over 2 minus 2, that's equal to 4 over 0, which is undefined. Okay, the vertical line has a slope that is undefined. All right? Graph shows a table of the relationship between the number of servings of salsa recipe makes and, not make sand, the ounces of black beans used to make the recipe. Use the table or graph to find the slope of the line. What does the rate of change mean in this example? Okay, what would the slope of the line be? Let's use the table. Let's just use this table. Right? Let's use these 2 points. So the slope would be
2 over 5.
Slope is?
Which one's X and which one's Y?
The Y is black beans.
The ounces of black beans, because the ounces of black beans depends on what?
How many servings?
How many servings I decide I'm going to make. So it's going to be 15 minus 10 over 6 minus 4, which is 5 over 2 is the slope. Now, what does this mean?
Every 5, when you go up, they go up.
Every 5 servings of, excuse me, every 2 servings of black beans requires,
5 ounces.
excuse me, every 2 servings of salsa requires 5 ounces of black beans. Yes.
Do they do it on the graph that, because I mean the actual slope is 5 over 2, but on the graph it looks like it would just be 1. Do they do it like that?
All right, so think about what's wrong, and that's a very, 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 very good observation. If we had a square, the square from corner to corner, from here to here, is going to go up 1, right 1. What's wrong with that assumption with this particular problem?
Because it's a broken
It doesn't
It goes
increase on the
right
second
to-
amount.
It's not a broken graph, but it is a completely different scale. This scale is going by 5s, and this scale is going by 2s.
4s.
2, 4, 6, 8. Who do we appreciate? Okay. All right. And these would be 5s. 5, 10, 15, 20, 25. So you got to. That's something you have to be really, really careful with. Liam, a lot of students aren't going to notice that looks like it has a slope of 1. But it really does. It rises 1, runs 1, rise 1, run 1, rise 1, run 1. But that's really rising 5 and running 2.
Which is why you said use a table.
Yes, always. Well, you don't have to always use the table, but that's a great observation that you made. Okay? Here's your homework. Yeah, grab your textbooks and get started on that. And I'm going to